Okay, so this is section 4.1, exercise 44. And in this, they want us to use technology with this differential equation, minus 1 over x squared, and we're told the solution goes through the 0.13, or another way to say it would be, y of 1 is equal to 3. Now I say a differential equation. A differential equation involves a derivative and an equation, equals. And so there can be various methods to come up with this. Basically you want to find the antiderivative when you're given a differential equation. But that could be hard in that you could actually have an implicit situation. So for instance, remember we did implicit differentiation, and suppose we had a circle of radius 2 like this, and we took the derivative implicitly. We got 2x plus 2y dy dx equals 0, and if we solve for dy dx, we get a differential equation that is minus x over y, like that. So that's implicit because it involves the function y, and so it makes things much, much harder to deal with. And and this differential equation might have had something like, when y equals 0, what am I trying to say? No, when x equals 0, right? Yeah. So y of 0 is 2, because if I put in 0 for x, I get y is 2. Okay, so, that could be a differential equation, and how might we solve that, Well, you might have to do it numerically, and we can get a sense of what's going on and get a nice graphical picture of all the antiderivatives. Because remember, this solution will have an arbitrary constant with a really nice, just graphical idea of, okay, we'll take a bunch of x and y's, and for each of those x and y's, dy, dx, we will calculate dy dx. And so, I could do like 1 and 2, and y equal 1, 1, and then x could be 1 and 2, and y could be equal to 2 and 2. And I evaluate that, and, well, it only depends on x. It's negative 1 over x squared. So here I would get a negative 1. Here I would get a negative 1/2. Here I would get a negative 1, and then a negative 1/2 again, because it only depends on x. But then what we can do with that is go here, and there's a 1, there's a 2, there's a 1, there's a 2. And at each of those points that we had in here, we can draw slopes. So this would be a negative 1 slope, and a negative 1 slope, and then a negative 1/2, and a negative 1/2. And then we could look at just kind of connecting the dots to get our solution. So remember, our solution goes through the point 1, 3. Now, I've had some trouble with Sage Cell and so forth going offline and so forth. So here, I'm just going to pull up a picture I did, and then we'll have a part 2 on this. But what I did, I went into Sage Math and just made a big slope field like they had in the book from x equals 0 to 7, and y from minus 4 to 4, and then did a screen dump of that into this thing, and here's the 0.13, and so if I connect the dots, it looks something kind of like this. And there's my solution, and does that looks probably about right. Now, why does that look probably about right? Well, we can go back and solve this thing. Right, we had dy dx is negative 1 over x squared, so that means y is the antiderivative of negative 1 over x squared dx, which is the antiderivative of negative x to the negative 2 dx. Now, power rule, right? I have a negative, and I have x to the negative 2 plus 1. Negative 2 plus 1 here, plus arbitrary constant. Now, full disclosure, yeah, I screwed this up in a previous video, so I had this part 1 before, and I screwed up this power rule. It can happen. You can have it. So it's hopefully not the end of the world. In other words, we don't screw it up when life is on the line, but it can happen, and I had accidentally subtracted 1 instead of adding 1. Bummer, wrong answer. So what we get here is a minus 1 there and a minus 1 there, so that's just a positive 1, and we get a minus 1 up there. So this is just positive x to the negative 1 plus c, or I could write it as 1 over x plus c. Now, and we're told that when x equals 1, so y of 1, which is equal to 1 over 1 plus c, we should get 3, in which case then c is equal to 2. Sorry, no equal sign there. C is equal to 2. Which means our function is y equals 1 over x plus 2. Now in part 2, I go through a whole bunch of stuff and do the same thing, and but in Sage Math, and produce a very accurate picture like this one here, but I get Sage Math to do it. Okay, so that's part 2. Okay, so number 44.